In this video, I am going to demonstrate exactly what I mean when I say that a function, such as the sine function, is approximated by a Maclaurin polynomial. So first of all, remember that a Maclaurin polynomial is a Taylor polynomial that is centered at 0. And so y equals x is the first term of a Maclaurin polynomial. And so you can see that the two functions, the sine of x and y equals x, the Maclaurin polynomial, the first term of the Maclaurin polynomial, agree completely at x equals 0. Okay? And for a little bit beyond that, we can zoom in and you can see that the two curves are almost identical, up to approximately, negative 0.2 and positive 0.2. So we could say that the first term of the Maclaurin polynomial approximates the sine function, but only over a very, very small interval. Well, what happens when we add the second term of the Maclaurin polynomial? Now we notice that the green curve, the second degree Maclaurin polynomial, approximates the sine function over a greater interval, almost to plus or minus 1. So we can see almost up to positive 1 and negative 1, the two graphs lie on top of each other. So the second degree Maclaurin polynomial is a good approximation of the sine function over the interval from plus or minus 1, approximately. What about when we have three terms? Well, now we can see that the Maclaurin polynomial is approximating the sine function up to approximately plus or minus 1.5. Oops, that's the same term. So add another term, and now, so now that it's approximating the sine function up to approximately plus or minus 3. Add another term. And we're getting a better and better approximation. So you can see what's happening here. As we add more and more terms to the Maclaurin polynomial, we're getting a better and better approximation of the sine function over a greater and greater and greater interval. Finally, taking up to this last one, so we have the first 6 terms of the Taylor polynomial. It looks like it's a pretty good approximation over the interval from about plus or minus 5. So remember that a Maclaurin polynomial or a Taylor polynomial is an infinite polynomial. And so all we're doing here is approximating it using basically partial sums. Y equals x is the first partial sum. X minus x cubed over 3 factorial is the second partial sum. And so we've got the third partial sum, fourth partial sum, fifth, sixth, seventh partial sums. And so the more terms that we add, the greater and greater the approximation. Finally, as we let the Maclaurin polynomial go to infinity with an infinite number of terms, we get a perfect approximation of the sine function over an interval of infinity. So you remember from the previous video, I said that the interval of convergence of the Maclaurin series is infinity, which means that when we create a Maclaurin polynomial and then a Maclaurin series from that polynomial, it is an approximation of the sine function centered at 0 over plus or minus infinity. All right, so that was the purpose of this, is to explain what we mean when we say that we are creating a Maclaurin or a Taylor series from a Maclaurin or Taylor polynomial that approximates a function. And so we liked it when the series, and a Taylor series and a Maclaurin series are both just types of power series, when the power series represents the function over an interval of infinity.